Hi, this is Larry Feldman with a lesson on geometric sequences. A geometric sequence is nothing more than a list of numbers with a common ratio between consecutive terms. So what do I mean by a common ratio? Let's do a quick example. Let's say we have 16, 4, 1, and 1/4. The common ratio is found by taking any term and dividing it by the previous term. So the common ratio is denoted by the letter R, and it equals 4 over 16. That's the second term divided by the first term. That simplifies to 1/4. It also equals the third term divided by the second term, so that's a fourth. And it also equals the fourth term divided by the third term, which is 1/4. And this could go on and on. So the fifth term is 1/4 times 1/4, or 1/16. So that's an important distinction. You find the common ratio by taking a term and dividing it by the previous term. But if you're starting at the left and moving right, you multiply by R. So 16 times 1/4 is 4. 4 times 1/4 is 1, etc. Now, let's say that we have position numbers for each of these numbers in the sequence. This is position 1, that's 2, 3, 4, and 5. There is an explicit formula which looks like this. A sub n equals A sub m times r to the n minus m. And this formula can be used for a variety of reasons. One of the main reasons is to figure out what the nth term will be given the mth term and the common ratio. But you can also use this formula to find the common ratio if you have enough information. So we're going to do a couple examples using this formula. And I just want to point out before we jump into that similar to arithmetic sequences, be cautious about only knowing or memorizing this formula. This is a formula that a lot of teachers like to discuss. It's a valid formula because all we're doing is replacing m with 1. Here's m. It's replaced with 1. Here's m. It's replaced with 1. This is a valid formula, and it works, but it can be limiting because it's usually only useful if you know a sub 1 or are trying to find a sub 1. Let's say that we want to find a sub 6. That's the sixth term here, and we know the pattern already. We take a term, we multiply it by 1/4 to get the next term. So this sixth term should be 1/16 times 1/4, which is 1 over 64. Let's see if our explicit formula will give us the same answer. So let me just jot that down again. And let's keep in mind that R is 1/4. I want to show you that this formula is very versatile because we don't even need to put a sub 6 on the left side. We can put, for example, a sub 3 over here and put a sub 6 in this spot. The important thing, actually let me erase that. We know R, so let's sub that in. The important thing is keeping track of n and m in their positions. N is over here. M is over here. This just matches our equation above. So what is this exponent? It's n minus m. So it's 3 minus 6, which is -3. If you make a mistake in the order, obviously that's going to throw off the problem completely. Let's keep doing substitution. A sub 3 is 1. We can just sub that in on the left side. We don't know a sub 6. And what is 1/4 to the negative third? Well, that is the same thing as 4 to the third. And if that's a little confusing, I would encourage you to check out my video on exponent rules. So let's keep going. 1 equals a sub 6 times 4 to the third. What is 4 to the third? 4 times 4 is 16. 16 times 4 is 64. And then we're going to divide both sides by 64. So we have 1 over 64 equals a sub 6. And that is the same answer as that, which shouldn't be a surprise. If it is a surprise, then you've lost complete faith in me. I want to show you another formula that's used for geometric sequences. So let me clear the screen here. And let's just rewrite the sequence. We have 16, 4, 1, 1/4, and so forth. This equation that I'm about to write is called the recursive formula. And it looks like this. A sub n equals a sub n minus 1 times r. It's a lot easier to look at than the explicit formula, but it's not as useful in general. So how does this work? Well, you start with an initial condition, usually a sub 1, which is 16. And then what you want to do is set n equal to 2 and sub that in to this equation right here. So if n equals 2, that means a sub 2 equals a sub n minus 1. So that's 2 minus 1 times r, and we know that r is 1/4. So a sub 2 equals a sub 2 minus 1 is 1 times 1/4. Let's stop here for a second. A sub 2, the second term is the first term times 1/4. That shouldn't be a surprise. A sub 2 equals, now we come to our initial condition, that's 16 times 1/4, which is 4. And that agrees with our second term. Let's do a sub 3. A sub 3 equals a sub 2 times r. A sub 3, in other words, a sub 3 equals a sub 2, which we just found. It's 4, right here, times r. 4 times 1/4 is 1. And that's our third term. So what's the disadvantage with the recursive formula? Well, it's very similar to the disadvantage of the recursive formula using arithmetic sequences. If you're asked to find a sub 100, for example, the equation is a sub 100 equals a sub 99 times r. And there's a slight problem here because we don't know a sub 99, at least not yet. So you can come down to this step. A sub 99 equals a sub 98 times 1/4. And you can see that we're slowly getting down to 1, but it would take a long time. So just beware that the conclusion is that the recursive formula is easier to use, but it's typically not as useful as the explicit formula. Okay, let's do one more example using the same numbers that we've been using throughout this video. We have 16, 4, 1, and 1/4. And this time, let's assume that you're asked to find n such that a sub n equals 1. In other words, what is the position number that gives us a value of 1? Now we know it's right here, and that's position 3. So we expect the answer to be 3. But it's okay that we know the answer going in, because this method can be used to solve any problem of this type. So let's start with our explicit formula. A sub n equals a sub m times r to the n minus m, as usual. And we know that a sub n equals 1. So let's sub that in. That equals a sub m. And we can choose any of these remaining 3 values if we'd like. Let's choose this one for now. So this is a sub 1 times r. We know that's 1/4 to the n minus m. We don't know n, but we know m. This is m, that's m. These values must be the same. So since we chose an m value of 1 there, we have to put that same value right up here. So let's keep going. 1 equals a sub 1. This is a sub 1. That's 16 times 1/4 to the n minus 1. Let's divide by 16, so we get 1/16 equals 1/4 to the n minus 1. Let's come up here. 1/16 equals 1/4 to the n times 1/4 to the negative 1. Now, how did I get this? I got this because when you multiply like bases, you add the exponents. So 1/4 to the n times 1/4 to the negative 1 is 1/4 to the n minus 1. Let's keep going. 1/16 equals 1/4 to the n times, what is 1/4 to the negative 1? Well, that's simply 4. Let's divide both sides by 4. That's 1/64 equals 1/4 to the n. And we know, or can figure out, that 1/64 equals 1/4 to the 3rd power, right? 1/4 times 1/4 is 1/16 times 1/4 is 1/64. So that gives us this value here of n. That's 3, and that's what we expected at the beginning. So that is it for now. Be on the lookout for a video about geometric series. Hope that was helpful, and I will see you next time. Thanks. Bye-bye.